Bismillah ar-Rahman ar-Rahim. The subject today is about the circular shift and the circular convolution. But we will start with the circular shift first and to introduce this new concept regarding the time domain sequence. So the main topic is the circular shift and the circular convolution. Okay, so we'll start with the concept of the circular shift. Circular shift. Circular shift is an operation implemented on the time domain sequences, discrete time sequences. So before we define the circular shift, let's define some new operation called modulo operation. So before we start to define the circular shift, let us introduce the modulo operation. Actually, the modulo operation is the residue resulted from the division operation. So we define the modulo operation in the following manner. R equals to M modulo N. So we use this symbol to represent M modulo N. So the result of this modulo operation is R, which should equal to M plus some L times N, where L is an integer, actually positive or negative, such that, or chosen such that, chosen such that R is a number between 0 and n minus 1. Let's take an example and explain it more. So if we take an example, taking a 50 modulo 7. So we have to look for an L. Actually, L is one unique number chosen so that the end result R should be between 0 and n minus 1. So if we say 50 modulo 7, so this is 50 plus some constant L, integer constant. In this regard, because this one is positive, we'll choose it negative, minus 7 times 7. So this is my M plus L times N. So M is 50, L we choose it to be minus 7, N is actually 7, which is here. So this result is 1. So 50 modulo 7 is 1. Actually, this is the residue coming from dividing 50 by 7. So 50 by 7 is 7, and the residue, or the what we have left is 1 actually. Okay, so if we take minus 50 on the other hand, modulo 7, so this is minus 50 plus, we'll choose here L to be 8 times 7. So this is my M plus L times N. and we have this to be 6. So the end result always should be a positive number between 0 and n minus 1. We cannot choose here 7. 7 times 7 is 49. Minus 50, this is minus 1. And minus 1 is not between 0 and n minus 1. So we have to choose a number, L, so that the end result is a positive number between 0 and n minus 1. Here, 0 is, and n minus 1 is 6. So you have to have a number between 0 and 6 because n is 7. Okay? All right. Now we are ready, after introducing this modulo operation, we are ready to go to the circular shift definition. So the definition of the circular shift is as follows. The circular shift, y of n is equal to x of n minus n0 modulo n. So we introduce the the modulo operation inside the index of the time domain sequence as shifted here. What we mean by circular shift, as we can think of it as we have the sequence itself on a circle. So if you shift it right or left, the one that goes out will go back to the empty space that is left by the shifting operation. We'll see this in the following example. Okay, so let's go see this example and see how we implement the circular shift. If we let x of n to be equal to 1, 2, 3, and 4, so we have 4 element, sequence of 4 element, and we need to find y of n, which is equal to x of n minus 2 modulo 4. So this is a circular shift by 2 steps to the right. Okay, those 2 steps can be implemented as follows. Step number 1, we will take 1 step to the right, 1, 2, 3, and 4. This 4 will go to the right outside, and it will go through a circle and substitute the empty space left by this shifting. So by step number 1, we have 4, 1, 2, and 3. In step number 2, because we have 2 steps of going to the right, the 3 will go out. So in step number 2, this 4, 1, 2, and 3, this 3 will go out and replace the 4 here. So this one will, the end result will be 3, 4, 1, and 2. So this is my y of n. So my y of n is equal to 3, 4, 1, and 2. This is what we call a circular shift. And by the circular shift, the sequence itself will stay with n number of elements. So we have 4 elements. The sequence will have 4 elements in this manner. In an alternative solution, using the modulo operation, we can start implementing y of 0 to be equal to x of 0 minus 2 modulo 4. And this is equals to x of minus 2 modulo 4. And this is equals to x of minus 2 plus 1 times 4. It's equals to x of 2. And x of 2, you can see that x of 2 here, x of 0, x of 1, x of 2 is 3. So this is equals to 3. Okay? Y of 1 is equal to x of 1 minus 2 modulo 4. This equals to x of minus 1 modulo 4. and this is equals to x of minus 1 plus 1 times 4, and this is equals to x of 3. And if you go to the sequence, x of 3, 0, 1, 2, 3, so this x of 3 is equal to 4. So x of 0 is equal to 3, x of 1 is equal to 4, sorry, y of 0 is equal to 3, y of 1 is equal to 4, and y of 2 is equal to x of 2 minus 2 modulo 4, and this is equals to x of 0 modulo 4. And x of 0 modulo 4 actually is 0 because we do not have to add any L times n. So this is equals to x of 0 plus 0 times 4, and this is equals to x of 0, and this is equals to 1. And y of 3 in the same manner, x of 3 minus 2 modulo 4 is equals to x of 1 modulo 4, and this is equals x of 1, and this is equals to x of 1 is equals to 2. So our end result, y of n, is equal to 3, 4, 1, and 2, which is the same result as we did graphically actually. Okay, thank you very much, and we will continue in the next lecture to present to you the circular convolution. Thank you.